let's see. I'm going to tell you a little bit about ManyClasses and how it responds to issues related to replication generalizability and how we can use open science to kind of do some of these things better. I'll tell you a little bit about terracotta. And in that way, I'm going to be skipping around a lot of different things. If you have questions along the way, I'd welcome you to just unmute and say, Ben, stop or something, because it's going to be hard to monitor chat. But if you want to put something in chat, and Trish or Will or Craig, you notice something in chat that merits a pause, then please, you guys have total right to say, Ben, slow down. Okay, so I'll start with replication because I think it's the obvious starting point in any discussion of research. So replication really is the cornerstone of all science. And the idea is that if there are systematic effects out there in the world, then those systematic effects should be observable under the same conditions if you have enough statistical power in whatever measurement tool you have. And there's been a crisis in our understanding of replication, not just in social sciences, but in all research, where people have been concerned that when you try and run the same study again, so replicating the study that a previous set of researchers have ran, it's not super well guaranteed that you're going to get the same exact results. In psychology, it's been estimated that we have a roughly 40% success rate at observing the same things that previously have been reported in the literature. But it's even worse in other domains, like cancer biology is especially bad. It's about 10%. And some of the studies in cancer biology are especially involved. So it seems to be clear that some process along the pipeline of doing your science causes your results to kind of veer off the branch of what you'd expect. And that pipeline tends to be such an important and yet underspecified thing that we have this crisis of whether our results actually are robust to the decisions that get made in those scientific pipelines. It's not just kind of like people who are really active in research that have been doing this. So it's been estimated that roughly 70%, so the majority of people who have done research at all have experienced some failure to replicate something that somebody else has done. And my guess is that if you're in this room, that's something that you've probably experienced yourself. One way of thinking about the replication crisis is that everything is crap and that nobody knows anything and that all of our effects that we know of are myths. But another approach to it, another way of thinking about the replication crisis, we could maybe even call it an escape hatch, is that it's not the case that effects don't exist. It's just that they really truly depend on these contextual properties of how a study was run. And really, we don't have a crisis of replication. We have a crisis of the ways that people are doing science, the ways people are making inferences, and that goes beyond what they're making claims that go beyond their initial ways of observing those patterns. This is something that was described in a Behavior and Brain Sciences article back in 2022 by a guy named Tal Yarkoni, who is a fascinating individual on his own. He now works for Google, but he previously was an academic researcher who really liked ice cream. To follow him on Twitter back in the heyday of Twitter when it was a nice place, you'd be just as likely to get brilliant science as you would be to get weird properties of squash flavored ice cream or something. But Tal put out a paper in BBS called The Generalizability Crisis, where he basically made the case that what's going on is not a crisis of replication, but it's instead the case that researchers are failing to specify the scope of their inferences. When we say that there's an effect, we're saying that there's an effect very broadly, even though the way that we measured that effect is quite specific to a particular way of doing science. And for that reason, we're kind of like stepping outside of the realm of what's allowable given the ways that we've run the study. It's like by doing science, by doing generalizable abstract science, what we're allowing ourselves to do is make claims about the world that don't necessarily work out in practice. And Tal went on to say that maybe if we forced researchers to need to think about things in practice, then they'd be more careful about what their inferences are, and we wouldn't have this crisis of generalizability. And that claim really stood out to me because I'm a researcher who studies practice. I study instructional practice and how that influences learning outcomes. I'm a cognitive psychologist, so I care very deeply about psychology of learning, but I'm very interested in how the psychology of learning affects educational practice. So this claim really provoked me. And I want to talk a little bit about learning and practice. So if you wanted to go out and do what Tal says and to make very specific claims about learning and practice, the way that you do that research-wise is by asking questions like what classroom practices result in better memory, or what interventions increase engagement, what materials improve performance. And all of these have the same general pattern of what X causes Y. What thing do we do to students that causes an outcome, causes them to have improved success or better test performance or more likely to enroll again? And if you're interested in causal effects in education, then the way that you do research on it is you run experiments. I care a lot about experimentation. It's, I think, the best way of being able to show a causal effect out there in the world. But it's also worth saying that experimentation is particularly hard in education. If any of you do research in education, it's almost as if every educational structure, every educational system is designed in just such a way as to make research more challenging, whether it relates to privacy or the way that class is structured or the way that technology is built. So it's for that reason that psychology studies are commonly conducted in controlled laboratory settings and not in classroom settings, which itself is an interesting problem. But things get especially complicated for those people who set out to do experiments on learning in practical settings. And I'll give you a very specific example so that I'm not talking totally in abstraction. Maybe you've heard of retrieval practice before. If you haven't, it's old. It's the idea that instead of just passively listening to something again or studying something again, the more effective way of learning something is actually to try and retrieve it from memory, which is paradoxical because if you want to learn something, it might not already be super well encoded in memory, but it's the process of trying to retrieve it from memory that turns out to result in more robust knowledge of things. This is something that was observed way back in the dawn of the dawn of empiricism. So that's Francis Bacon with the funny ruffles on his neck. And he once wrote, if you read a piece of text through 20 times, you will not learn it by heart so easily as if you read it 10 times while attempting to recite from time to time and consulting the text when your memory fails. A few centuries later, William James, some would say like the grandfather of psychology, at least in this continent, wrote, in learning by heart, for example, when we almost know the piece, it pays better to wait and recollect it by an effort from within than to look at the book again. And in a 2013 article about how what we know about the science of learning could be leveraged to improve student performance and educational outcomes, it was basically said that retrieval practice or practice testing is one of the most robust effects that we can take from psychology into the classroom. It was said it benefits student performance across a wide range of criterion, tasks, and retention intervals. Okay, so there's this strategy out there in the world, retrieval practice, and one would say that if we did that in an education setting, then we might expect that people would do better. And that's basically what these researchers did here. So in 2018, so this is before the generalizability crisis, Regan Gurung and Kathleen Burns ran a study where they took 8 nearly identical introductory psychology classes with almost 500 students total. And in 4 of these classes, students were explicitly encouraged to practice retrieval on homework quizzes. So they would do a homework quiz and then do it again and then do it again, basically trying to achieve mastery. And at every step of the way, trying to do it from memory rather than just trying to consult the text to improve your score. And in 4 of these classes, that encouragement didn't exist. So it was the case that students were just given the quizzes and they were not told to do it again. And what they found, paradoxically, was the students who took the quizzes multiple times actually had lower exam grades and course grades than the students who took the quizzes only once. So the actual change that they made on the basis of legitimate theory turned out to not work. And it wasn't because there's no such thing as retrieval practice. Again, we've known about retrieval practice since Bacon. It's something that's pretty well demonstrated in controlled settings. It's instead the case that weird stuff happens when you go out and run experiments in the field. So I want to argue that Yarkoni's kind of wrong that applied research is more specific about the scope of improvement, because I study education and I look at the education research literature, and when people set out to improve education, they still get into this habit of making grand claims about what works well outside the scope of what their own methods would have entailed. But I do then think Yarkoni's right that researchers aren't super clear about the scope of their inferences. So yes, generalization is a key goal of applied research, But there's two issues out there in the world. One is that the generalizability of findings is almost never tested in education science. When somebody wants to run a study to demonstrate an effect, they that's generally like the end of the story. Like they run a study, they find something, and then that's as if it's all we need to know. And when people do run studies in education settings, they find that the original results aren't super robust. So there's been different estimates of the robustness of education science. One claim is that there's about half of published replications that show effects that are consistent with the original observed research. But in the United States, there's been an organization called the Institute of Education Sciences, where they've actually been running replication studies and funding replication studies. And for them, about 1/3 of IES-funded replications find evidence that's consistent with the original result. There's been a lot of hand-wringing about what's going on in education and why this is the case. So it's probably something a little bit like what Talia Arconi said, where we think when we run a study and we don't observe the effect that's consistent with the original effect, that maybe there's something just wrong about the way that we did it. We tried it in a different setting or with a different pipeline or with different kinds of students. And that's a particular problem. It's a problem that's been referred to as experimenters regress. And it basically means that when negative findings are observed, you're screwed. So if negative findings are observed in an experiment, it could be one of two different things, and you don't know which one is true. It could be that the original effect is wrong, or it could be that when you tried to observe that original effect, you just didn't do it correctly. So if this is the problem, then you just need to rerun the study and then try and observe the effect. And maybe that fails again. And then you try and rerun the study, and maybe you'll try it in a slightly different way, and maybe that'll fail. And it's unknown exactly when you give up or whether you decide at the end of the day that there's some sort of hyper-contextual nature of this finding. And this is a problem when you do research the way that it tends to be done in education. And that's that it's usually done just on one class or in nearly identical class settings. So the study I talked about previously with Garung and Burns, it was 8 classes, but they were 8 nearly identical classes that were only at 2 different institutions and that had the exact same curricula and the exact same tests and everything. So even in that situation where somebody worked hard to find a collaborator and went beyond just the context of their own instruction, it was still just one kind of context. And when experimental research on classroom learning is conducted in just one class, it's unclear what to do with your negative findings. You get into trouble with experimenters regress. It's unclear whether the results that you observe would generalize to new classes. So just like it's questionable whether the original study would generalize, it's questionable whether your new study would generalize. And more broadly, it's unclear why the results were observed. Okay, and I'm getting closer to openness, I promise. If this is the problem, where in education research, people tend to only run studies in one class, then the solution is like totally knock your head on the floor obvious. You'd need to run it in many classes. And that's basically been the adventure that I've been on throughout my professional research career. And I'm not the first person to say this. In fact, in the time since I last presented to POSE, I came across an amazing book. It's more like a monograph, but in 1913, there was a school examiner named W.H. Winch who set out to do an experiment, but rather than do an experiment in just one context, he was a school examiner, and he had the ability to go around to all the different schools within his ward. This is somewhere in like the UK. I think it was in London. Go out to all the schools in his ward and try out different things in the different schools. And his particular study was really fascinating. It was addressing a really hot topic in 1913 on the difference between inductive learning and deductive learning. At the time, deductive learning was the norm. So people would stand on a lectern and tell students rules that they were then expected to generalize to the problems that they observed. That's what deduction is. But there was this new fandangled approach that was inductive learning, where people would actually practice and be given examples of how, and they were supposed to then induce what the general rules are. So there's this, I don't know, dichotomous question of whether induction or deduction would work. And he's wondering this, and he says, what then do I suggest if we're curious about which one's more effective? I propose the experimental determination of these disputed questions in the schools themselves. There's an increasing number of teachers willing, nay, anxious, to carry out such experiments if adequate guidance be given to them, To the description of one attempt at an experimental solution of some of these disputed points, I now proceed. And just like Winch, I'll now proceed to tell you how we've done it with ManyClasses 1. Okay, so the first ManyClasses study was published in 2021, and it investigated how the timing of feedback affects student learning. Feedback is the one universal thing in all education systems. There's no such thing as an education system or program or experience that doesn't have feedback. If it did, it wouldn't be educational. It would just be observational. And for that reason, when a teacher is administering feedback, there's an implicit question, if not an explicit question, of when the feedback should be provided. Classic educational doctrine is that you need to give feedback immediately. Like as soon as a student makes a mistake, you need to tell them, hey, you made a mistake. This goes back to like behaviorism and the idea that rats learn best if you administer an error signal right away. But in contemporary education settings, it's not so clear whether people are the same as rats. And it might be the case that delaying the feedback by a little bit would improve student learning. It would get them to look at things in a new light after a delay. For ManyClasses 1, we used teachers' own materials, and we allowed teachers to determine many aspects of the study implementation. So it wasn't the case that I said to a group of teachers, hey, you've all got to go and do things the way I'm telling you. Instead, we harvested what we imagined to be authentic examples of how classes worked in the real world. And we documented those, and we took their materials that they created and made those the study materials, getting their agreement, obviously, to share so that we're not just kind of providing the results of a study on the timing of feedback that's unique to one particular mode, but instead that's generalizable across a range of modes that are well documented. And the range was 38 classes total. So this happened in the Unison Consortium, where 5 different institutions and 15 different college campuses collaborated. Across these 38 classes, we had about 3,000 students enrolled, so rough mean of 77 students per class. And we did ask for students to consent to participate. We didn't do ManyClasses 1, or I actually don't do any of my research in classrooms nefariously behind the screen, just pulling strings where they don't know it. All of my research is very transparent. So students consented to be a part of the experiment. They knew that we would manipulate certain aspects of their educational experience, and they agreed to share their data with us as well as to be a part of the study. I'm giving you this presentation. Trish introduced Ben. This is like the Ben show, but this is not, ManyClasses 1 is not the Ben show. There were so many contributors, and it was only made possible by the fact that we had a large number of contributors. On the far right, I'm joined by a few leads, Emily and Josh and Paulo and Rob, and Janelle was a key research kind of like administrator throughout the process. And all the teachers who were collaborators are also included as co-authors on the paper. And yeah, we also have to acknowledge the fact that their institutions went through some acrobatics to try and make it possible to share the student data. Even though we had consent, still getting access to student data was challenging, and getting IRBs figured out. So it's not a solo project to do collaborative distributed research and education. And some of the principles of open sciences I'll get to in a little bit make this collaboration much easier. So I'll tell you a little bit more about the study first so that it makes more sense what we did. Use Canvas at UBC. Yes. So from the student's perspective, if they were to take a quiz in Canvas, and these are all rendered as multiple choice quizzes, you hit submit quiz, and then there's one of 2 different screens that you see. On the left, you see the screen sometimes if your instructor has not allowed you to see feedback. But if your instructor has allowed you to see feedback, then you see the screen on the right. So on the left, in the case where your feedback is delayed, it says your quiz has been muted. And this happens all the time. It's not just a weird thing that instructors do. They do it because if you let students see the feedback right away, then you're basically releasing the right answers into the wild while students are still taking the quiz. So instructors reasonably might want to withhold the right answers until a whole bunch of students have taken the quiz and maybe give it a day or 2 before they release the feedback. Alternatively, if you're interested in formative assessment, maybe you really care more about students getting immediate feedback and you'd let them see the feedback right away. And that's the fundamental distinction in this study. It's one that can be done natively in Canvas without the need for any special software. The actual experiment design looked something like this. We had 38 classes on the far left. And at the class level, we had this idea that was really important. We realized that sometimes we're going to be delaying feedback to students, and that would create a confound, because maybe when feedback is delayed, then students are going to be less likely to look at the feedback because it's been delayed. They're no longer in the context of quiz. So in some of the classes, we assigned the whole class to an incentive condition. And in that condition, students were incentivized to look at their feedback. They actually got an email when the feedback was released saying, go look at the feedback and also respond to this assignment about the feedback. So we could confirm whether students had looked at what they got right and what they got wrong. The assignment actually was up to the teacher, like everything in this class, but usually it took the form of a teacher saying, what was the hardest question? Or what was the question that you got wrong that you think you should have gotten right, or something. So something that caused them to actually look at what they did. Again, informed consent was implemented. We protected the consent decisions that the students were rendering from the instructor, so the teachers never knew who was consenting or not. There was no power dynamic that was problematic. And then it was what we would call a within subject crossover design. So a student who got delayed feedback on homework 1 and then took a test, then later in the class would get immediate feedback on the next homework, and then there would be a test of that. And vice versa if you started with immediate feedback. So another thing that's important about ManyClasses studies, we're sensitive to the concern that maybe there's going to be bias due to experimental treatment. Like some students get the immediate feedback, and if it turns out that immediate feedback is better, then we've disadvantaged everybody who got the delayed feedback. So we solved that problem by having everybody get all treatments just at different times. And it also improves statistical power, gives us some other cool opportunities with analyses. So that's the general design. And let me tell you about some of the open science things we did. So we registered it. The design was well established long before recruitment. We didn't make this up on the fly. It's really important when you're doing things collaboratively to say ahead of time exactly what you're going to do so that institutions and teachers know what they're signing up for. Beyond just registering the design of the study, ManyClasses 1 took the additional steps of creating an analytical plan based on simulated data. So we actually created data sets that were like what we expected to observe from the classes, and then wrote a script that carried out all the analyses that we intended to do with it. And that was key because it made it so that we weren't saying, we'll figure out how to do the data analyses later. Again, when we were approaching institutions, we were able to say, no, we know exactly what we're going to do. We know what the structure of data needs to be. And this is the scope of what we'll be doing with it. Given an analytical plan, it was pretty easy to then submit a registered report to a journal. A registered report is a special form of writing open scholarship, where you submit to the journal not a completed manuscript, but what's called a stage 1 manuscript, which is a manuscript that doesn't include any data or results. The data and results, and even some of the discussion, are contingent on what you do after the manuscript gets accepted. So the idea is that we shouldn't judge a manuscript on the results. We should instead judge a manuscript on the quality of the research that's going to be conducted, so that we're not doing publication bias and stuff. So once we submitted the registered report and it was accepted, then we pre-registered the full stage 1 accepted registered report. Okay, this was a ton of work. It meant that we were really busy doing research even before we got the research going. But it had a lot of really strong advantages. As I mentioned, it helped during recruitment. So we could say to institutions, hey, this is what we're going to be doing, and this is the full range of everything that we plan. That also helped for institutions to give approvals. It also helped for IRB to give approvals. And it also helped with analysis too. So it was the first time in my experience that things had been so well established that the process of going from data collection to publication was very short. It was like we didn't have to make things up as we were going along. It was a boon for the process of getting research done. Now I'll share with you the results. I guess that's part of the interesting thing about research, is not just how we did it, but what we found. I'm going to show you what's sometimes called a forest plot. And I've laid it out such that every class is going to be a point that we're going to stack up. And on the left, the points would mean that delayed feedback is better. And on the right, points would mean that immediate feedback was better. So for example, this is pretend data, but imagine that I put a course right there. It would indicate that in that course ID 31, there was a tendency for students to do better on downstream tests when they got immediate feedback. It's also the case that there's this like line in addition to the point. That's the 95% highest density interval. It's like the uncertainty of our estimate of the quality of the effect. That interval could overlap zero. And if it's overlapping zero, it would suggest that we don't really know whether delayed feedback or immediate feedback is better within the scope of that class. These are situations where the class was red, so the incentive condition was no. We could also have a class where it's blue, and that means that there was an incentive for students to look at the feedback. We could also observe things on the other side of the graph. You get the rough idea of how these things work. Yeah. Okay, so I'll show you the real data now. Drum roll. Boom. Okay, 36 classes, and almost all of them are very close to zero. There are 0 classes that deviate from zero. It's the case that 100% of the classes in this sample showed no strong effect of the timing of feedback. And I can, rather than rendering it as a forest plot, just pool all the data together and make curves where I try and show the actual posterior estimate of what the benefit of immediate feedback is. And it's like sharp on zero. So it's not the case that we have uncertainty in our estimate. This is one of those rare cases in science where it's clear that the effect of delaying or immediate feedback, the effect of feedback timing is zero at the very high level. So there's no broadly generalizable difference in learning performance across classes when students receive immediate feedback compared with delayed feedback. Okay, if you accept that as an outcome, then my guess is that you're kind of curious, but it's not perfectly lined up on zero. Like this class down here, this one does seem to be drifting in the direction of immediate feedback, and these ones up here seem to be drifting in the direction of delayed feedback. So is there anything systematically different about the properties of a class, which I told you before was something that we tried to document really well? We had dozens of moderating variables. So we took the class materials that teachers provided and tried to create, we quantified it and tried to do moderator analyses, and basically found no strong evidence of systematic differences in effects of feedback timing between students or between classes. That caused us to be a little bit concerned because we do believe that there are differences in educational effects, and we do believe that some of these things should moderate things. So we looked specifically at we drilled deeper into 3 moderators where we had reason to think that there might be an effect. And for these 3 moderators, the number of treatment quizzes, the length of the delay, and the percent of retrieval-based items, I'll show you another view of the results. Here I've kind of twisted it. So the classes are now vertical intervals, and every dot is still a class. And on the far left, you see how increasing the number of treatment quizzes in classes might moderate the benefit of immediate feedback. So if the class is above zero here, it would mean that immediate feedback was better. If it's still below zero, it would mean that delayed feedback is better. And you can kind of see on the far left that as you get a larger number of treatment quizzes, there tends to be a slight benefit for delaying feedback. Like the red lines tend to go down here. But it just was narrowly within the range of what we would say to be zero effect. So our 95% estimate slightly overlapped zero. We also looked at the same thing with the days between due date and delayed feedback. This is like how long the delay was. And similarly found that as you get longer delays, we tend to see increasing benefits for delayed feedback. But again, our estimates are pretty close to zero. And here we look to see whether the number of retrieval-based exam items, these are like fill-in-the-blank questions, might moderate the influence of feedback timing. And again, we see this slight trend for there to be an effect where there's a benefit of delaying feedback, but still our estimates are pretty close to zero. So we've got these directional trends that suggest that increasing the dosage of feedback and the length of delay could result in benefits for delaying feedback, especially when the class is incentivized to look at their feedback and when the tests are retrieval based. But check this out. We only had like 6 classes in this part of this graph, or 6 classes in this part of this graph. And only 25% of the whole sample had greater than 50% retrieval-based exam items. So we had just had sparse coverage in the regions that would be necessary to be able to demonstrate a robust moderating effect of the differences between classes. Okay, so some conclusions from ManyClasses 1. It's easy to say this is as close to truth that I can get in my research. There's no single invariant benefit to immediate or delayed feedback. So it's not the case that timing of feedback has one effect that generalizes across classes. By all means, it seems to be the case that if there is a general effect, it is zero. So pinning down the settings where benefits might be observed will require even larger samples. So we do see some hints for delaying feedback being better, but they're just in undersampled contexts that might be relatively rare in education. It's nevertheless the case that we pulled it off. Large-scale distributed experimentation in online learning settings can be feasible, but it's still hard. So it did take a long time to do this study. And yeah, if we're going to be able to run things at larger scales, then we need to overcome some of the challenges in running these studies. So I also want to say that large-scale distributed experimentation, if we're going to make it more routine, needs better tools. So that's this other thing that I've been working on. I've been working on a plugin to the learning management system that makes it so that we could run ManyClasses studies more easily. And that's what Terracotta is. So I'm not going to go into great detail about it. I'm actually a horrible salesman, and it's not something that I'm selling. It's totally free and open source. So all the more reason that I'm a horrible salesman. You could go and download Terracotta if you wanted and run your own instance of it. But it's described at terracotta.education. And the simplest way of describing it is it's an A/B testing tool for instructional design in Canvas. A/B is an oversimplification. You could run experiments with up to 16 different conditions and very sophisticated designs with multiple within subject crossovers. But it gets you the state where you can measure how the things that you do in Canvas influence student learning in situ in a relatively easy and flexible way. So if you set up an experiment in Terracotta, then you can create an assignment like a Canvas assignment. There's assignment 1, it's a Canvas assignment. And that assignment can have different versions. So there can be version A of assignment 1 and version B of assignment 1. And then Terracotta is going to randomize which students get assigned to version A and which students get assigned to version B. And it's going to take care of a lot of the things that would otherwise be relatively challenging. It doesn't, as I mentioned before, it doesn't need to end with one assignment. It could be something that's a repeated measures design. So you could add multiple assignments. A common criticism of experimentation in education settings is that it tends to be like this one-time thing. Like we're going to give you a treatment and then hope that there's some massive effect of it. But with Terracotta, it doesn't need to be a time-bounded thing. You could experimentally manipulate somebody's weekly homework assignments for weeks or for the whole semester. And that makes it so that we can measure more impactful and more robust effects. Another thing that's really exciting about Terracotta is the blue export data button up there. So from the teacher's perspective, you don't need to make a request to your IT unit or to some data manager somewhere else. You can download the data directly to your browser from Terracotta. And Terracotta does the things you'd want it to do with these data. It rigorously de-identifies it so that there's no hint that there's anything in the data that would cause a student's identity to be clear. And it also filters out anybody who didn't provide consent. As I mentioned before, consent is a cornerstone in a lot of the work that I do. So Terracotta also implements a full informed consent workflow. It does this by creating another Canvas assignment. So it's a consent assignment, and it displays an informed consent statement. And it presents students with a single prompt. So in consideration of the above, will you participate in this research study? And students can render their response. And this is a special kind of assignment because students get credit no matter what their response is, and teachers can never see what their responses are. Again, trying to prevent a power differential that might cause students to feel coerced to participate. So Terracotta tries to do things as ethically as possible. And can I tell you the most exciting thing about Terracotta right now? This is only like 2 months old, and it makes me so happy because I've started playing with it already, and it makes so many things possible. So Terracotta can be middleware between Canvas and something else that you create. So let's say that you use Qualtrics. Does any of you use Qualtrics ever? You could imagine yourself using Qualtrics to make any old sort of learning activity. So people can watch videos or do activities in Qualtrics, and you can render it as an assignment in Terracotta. So including grade passback and everything. So from the student's perspective, they're responding to a Canvas assignment, but it's actually something that you created natively in Qualtrics. And that's just the example of what would happen with Qualtrics. If you have the wherewithal to make your own learning activities on the web, then you can also implement those as Canvas assignments. And we use a really robust single-use token system to maintain the integrity of activities, but it basically makes it so that we're democratizing the student experience of the LMS. You don't have to be a big, bad, bold ed tech corporation to get something integrated into Canvas. It's the case that innovative teacher or researcher who's got an idea about research-informed practice can easily pilot something in Canvas without needing to go through the hoops of getting a full integration. Okay, so this is what Terracotta does, and it's pretty cool. I'm very excited about it. I want to tell you about how we use Terracotta in an additional ManyClasses study real quick. You have appetite for one more ManyClasses study? Okay. Right at the time that when we were building Terracotta, there was this wild thing that came out called the X Prize Digital Learning Challenge. I've never participated in anything like this before, but it's worth kind of flagging it because I think that we're going to see more of these as research funding gets strange. So the X Prize Digital Learning Challenge was a grown-up science fair. Like literally, it was a competition between researchers to build a platform to run a digital learning experiment in some digital learning platform where we weren't going to get funding on the front end. Like we weren't going to get funded to do the study. We were going to get an award at the end if the judges liked our experiment well. So we entered Terracotta into the X Prize Digital Learning Challenge and proposed running a ManyClasses style study. And the whole point of the X Prize Digital Learning Challenge was to basically cause experimental research to accelerate. So the goal of the X Prize Digital Learning Challenge was to enable experiments of frequency, scope, and scale not possible through traditional methods used in educational research or commercial ed tech processes. It was a 2-year adventure, but the real fun part was September to March 2023, which was the demonstration phase where we actually tried deploying a study across dozens of classes in a very short period of time. And we won the runner-up prize, which I'm very proud of. The team that won the first place, they were an AI tool, and 2023 was the year of AI, so I was bound to lose. But yeah, we tied with Carnegie Learning, so that's a win in my book. Okay, what was our research study? We looked at something called pre-questions. Have you heard of pre-questions before? That's a pre-question. So it's a question that you ask people before they learn something. So questions in education obviously have different purposes during learning. So commonly, if you used a question like on a final exam, it's a way of evaluating knowledge. But you could also use questions to help people form knowledge, and pre-questions are a special category of that. So for a long time, people have looked at questions that are administered on the kind of beginning before somebody learns something. And there's this cool study like 100 years ago again, where Washburn put questions at the beginning of a textbook chapter and at the end, and found that the grouping of all questions at the beginning of the story was the best placement. People have looked at the pre-question effect as being something that might even be bigger than retrieval practice effect. So the effect of administering questions is bigger if it's before somebody learns something rather than after. But we're totally unclear in the literature about why pre-questions help. There's been so many different research studies that have claimed so many different things. One is that it could demonstrate knowledge gaps. It could activate a relevant mental model. It could help with error processing, could just cause people to be more curious and give more attention to learning materials. Maybe it's a priming effect. So we ran a ManyClasses study on pre-questions for the X Prize Digital Learning Challenge using Terracotta. It had the same basic structure. So there were 26 classes. Actually, that's an error. It should be 30. I'm excluding some classes here in this slide, but there was a within subject crossover design where for some students in one homework, they saw pre-questions before watching a video, and for other students for that video, they saw no pre-questions, and then it flipped. So it was a within subject crossover design. And then afterward, they got the same questions that would have been pre-questions. So we were measuring how much they learned from the video. There was no feedback or points on pre-questions. It's worth kind of giving you that, like putting an asterisk on that. You can't grade students on stuff that they haven't learned yet. So pre-questions were not graded. They got credit no matter what their response were. And the test questions were identical or near identical to the pre-questions. They had to answer them, nevertheless, to advance to the video and to receive credit for the whole assignment. They could stop and pause and move around the video, but they had to claim that they watched the video. They had to click a button that says, I confirm I've watched the video. So just to give you another way of looking at it, every student watches 2 videos at some point, but only one of them is preceded by questions. The questions are relatively hard, but they're answered within the video. So they either watch the video with a pre-question like at the top or watch the video without pre-questions. Here are those 30 classes. And one of the things that made the second ManyClasses study fun was that we went all the way down to 6th grade. So we included pre-college students. The 6th grade classes were Spanish. That was also interesting to have formal language classes. But we also had some very advanced classes like business collaboration or some veterinary medicine classes that were taken by college seniors. Overall, we had 3,300 students enrolled in these classes, but we saw a smaller consent rate. So we only had about 1,500 consenting students participate. I'm going to show you the results. Here, even though there is a lot of overlap in any individual class with 0 effect, here it's an odds ratio, so the number 1 is like 0 effect. We nevertheless saw a reliable improvement at the overall level on pre-tested material. So when you saw pre-questions, you learned the material from the video better than when you didn't see pre-questions overall. So it's not like timing of feedback where there's no general population scale effect. Here, there does seem to be a general effect. But that effect is heterogeneous. So we do still see like big differences between class ID 68 and class ID 226. Moderator analyses did find statistically credible effects. So we do see that there's larger benefits for pre-questions when those pre-questions are easy. And we also see larger benefits for pre-questions when students have some relevant prior knowledge. So when they're doing relatively well in the course, or when they do well on some of the pre-questions, when they answer some of them correctly. So it's not the case that there's this 5% improvement overall. It's the case that there's overall an average improvement, but it differs across classes. We also found this really fascinating thing. Okay, let's imagine you're a student in this class and you're encountering pre-questions before being shown a video. After answering the pre-questions, you could do one of 2 things. You could start the video. You could like go and do the thing that we expect you to do, watch the video and then learn from it. Or you could answer the pre-questions, get to the video, not start it, and just click to confirm that you've watched the video. Basically, you could lie. And what we found to our surprise was that pre-questions actually increased the likelihood that students might not watch the video. And curiously, we found that the students who didn't start the video had lower performance in the class and also had lower performance on the pre-questions. So there was a pattern that we hadn't expected where if students don't know the material that's pre-questioned, they're turned off by pre-questions. So it's the case that they encounter the pre-questions and basically we could say that they might have become disengaged or become demotivated by not knowing. In spite of this, we still see a global benefit of pre-questions. So these students who don't start the video are a small number of the class. But nevertheless, for those students, pre-questions actually have some harm. Okay, so takeaways from ManyClasses 2. Really, research infrastructure is key. We really want to be able to run studies at larger scales, and to make it possible, it's helpful to have tools like Terracotta that can make that possible. It's the case that learning interventions can generalize across dissimilar classes. So we do see a global effect of pre-questions, but it's non-homogeneous. So there's a phrase that I like in education research where we call the pre-question effect like a rich get richer effect, where maybe students who already have some relevant knowledge benefit more from the intervention than students who don't have relevant knowledge. So this has been revealed with the treatment by behavior interaction, which we're kind of excited by. This is like experimental evidence of what we started with Talli-Arconi, the claim that maybe things depend more than how researchers have described it thus far. So there's a big science picture to mention, and that's that small sample research on what works is just not well suited to answer the question, what works? So we propose with ManyClasses a way to facilitate experimental research that addresses what works at scale, and it involves running the same study across multiple sites and contexts. ManyClasses is just one model for this. There's other people in other labs who are exploring alternative means. So large-scale distributed research is not something that I own. It's something that I think is taking off in lots of different ways, and it's an exciting time for it. And the open science picture is that it's useful and it's possible to tackle issues of generalizability head on. And it's especially helpful if you're going to tackle issues of generalizability head on, to have implementations that are super well documented and that are publicly accessible, so that when you're going to other sites and to other teachers, they're aware of what's involved, and also there's transparency about what the research is going to do. In open science, I think about the kind of research that I do as providing a fishing pole and not just a fish. I'm not just saying like, hey, here's the result of my study. I'm saying, hey, here's a fully worked example of how we ran the study. So in the case of Terracotta, there's now an open source tool that enables people to run better research. And my analysis pipelines are complicated. I use within subject hierarchical Bayesian models. There's like a whole separate universe of Bayesian stuff that's mind-blowing. And by making my materials available, I'm making that stuff a little bit more accessible to people who might not be super familiar with it. And other things that we do in ManyClasses is also helpful for educational research writ large, like making our IRB protocols totally public so that people don't have to reinvent the wheel if they wanted to do distributed experimentation. And also, I think it's key to normalize public pre-registration. So give examples of what this kind of research is like in a way that people can see ahead of time that this is the way that we'd want to be running the study. Okay, so that's my song and dance about ManyClasses. I want to offer you many thanks too for your time. And if you have any questions about it, I'd be super excited for them.